Welcome to Chapter 16. We are still working on acid-base equilibria. And this is part 2. We're going to focus on the function of water in the area of weak acids and weak bases. So water is very important in these reactions because if you recall, a weak acid or a weak base dissociates just a teensy-tiny bit. But so does water dissociate just a teensy-tiny bit as well. So there can be some interactions between them. So water is amphoteric, also known as amphiprotic. And do you remember what that means? That means it can act as either an acid or a base. How does it do that? How does it do that? There's a nice little picture of a drop of water. Well, if you can recall, HOH can on occasion come apart in very teeny tiny amounts. In a glass of water when you're drinking it, a few of them have come apart to this reaction. Kw, which is known as the ion product constant or the dissociation constant for water, has a constant number. And you should be able to recognize, since it's a 1-to-1 ratio, that for Kw will equal to the concentration of H3O plus multiplied by the concentration of OH negative. And at 25 degrees Celsius, those two numbers are the same in any particular cup of water. So the amount of concentration of the hydronium ion equals the hydroxide ion concentration. And both of these happen to equal 1.0 times 10 to the negative 7th molarity. So what is Kw? You should be able to figure this out. Kw is equal to 1.0 times 10 to the negative 14th, no unit. All right, let's look at an example, and I'm going to give you the answers at the end. For A, if you are given 1.0 times 10 to the negative 5th molar OH negative, what is the hydronium ion concentration? Remember brackets, and hydronium ion is the same as H+. And is this an acid or a base? Do you know? Part B, you are given 10.0 molar hydrogen ions in a solution. And so what is the hydroxide concentration? And is this an acid or a base? That's the question. A little review, hydronium ion concentration. If it is greater than the hydroxide concentration, what is it? An acid or a base? This is an acid. What if it's the other way? If the hydrogen ion concentration is less than hydroxide ion concentration, kind of sounds like Arrhenius, we can define this as a base. That would be a base. Let's look at a little question here. At 60 degrees Celsius, Kw is 1.0 times 10 to the negative 13. Remember, the equation is still the same. It comes apart to a water molecule comes apart and forms this. So the question here, there's two parts. A, is this exothermic or endothermic? I'm going to answer it in just a moment. And here's the answer. Since Kw has increased, you notice it's times 10 to the negative 13 instead of negative 14, then heat must be a reactant. Therefore, this is endothermic. It's absorbing heat. And part B is, I want you to tell me the concentrations. Tell me the concentrations for H3O plus and OH negative. Now remember, Kw are those equal to if they are multiplied. In this particular case, Kw is 1.0 times 10 to the negative 13th. So what's the molarity or the concentration of each of those? It is 3.0 times 10 to the negative 7th molarity each. Let's go back to this, and here comes the answer. The hydrogen ion concentration is 1.0 times 10 to the negative 9th molarity. And acid or base? This is a base. And the next one, what is the answer for this one? The hydroxide concentration is 1.0 times 10 to the negative 15th molarity. And this one is an obvious acid. And this, that's a foot. End of part 2. It's not my foot, but it's a foot. End of part 2. Welcome to chapter 16.